Now, beyond the orbit of Neptune, we have two regions. The first one ranging from just beyond the orbit of Neptune at 30 astronomical units away from the Sun to about twice as much, 60 astronomical units. We have this flat, ring-shaped region known as Kuiper belt, which contains the nuclei of so-called short-period comets. And then, at even greater distance, we have this spherical shell-shaped region with the inner radius of about 50,000 astronomical units, and the outer radius twice as much, 100 astronomical units, which is filled by the nuclei of so-called long period comets. And it turns out that Oort cloud was formed after the planets around the Sun were formed early on in the history of the solar system. This ring-shaped region, Kuiper belt, was at that time much more massive. Its mass then is estimated to be about, or was 100 times bigger than it is right now. And the objects in this ring-shaped region interacted with outermost planets, Neptune and Uranus, that caused some of these icy bodies to be scattered in all possible directions, forming this spherical shell region called the Oort cloud. Here is the photo of a nucleus of a comet. It's a mixture of ices, of water, carbon dioxide, methane, ammonia, and silicate rocks. And it resembles in its structure what one calls dirty snowball, right? Snowball mixed in with stones. And when the nucleus is far away from the Sun, it receives little solar heating. Therefore, these volatile substances forming ices are still part of the nucleus. But then once the nucleus gets close enough to the Sun, it's inside the orbit of Jupiter, closer than about 5 astronomical units from the Sun, it starts receiving enough solar heating so that these volatile substances forming ices start to evaporate, and the comet develops a tail.